All right, so here we have lesson 3. This is in module 2, and we're going to continue with statistics. And today we're taking a look at data sets of two variables or categorical data. So categorical data is data in the form of categories rather than numbers. So we're looking here at categorical data, which just means we're talking about categories rather than numbers. So when we talk about that, we're talking more about frequency. So maybe how many people enjoy something or how many people bought something, as opposed to the numbers having a specific value. So here, some categorical variables include gender, colors, animals, vehicles, and yes and no responses. So again, these are things that the answer isn't a number, but more we're counting how many people gave that answer. So a two-way frequency table is a table used to organize bivariate. So when we see the word bivariate, bi meaning two, variate representing variable, or two variable categorical data. A two-way frequency table places one categorical variable as the columns of the table and the other categorical variable as the rows of the table. So data regarding both variables is summarized in the body of this table. So now we're going to take a look at a sample question here. So it says, at a camp, 45 campers each chose one sports activity and one art activity. So when we're looking at our two different variables, the first one was the sport activity, right? And there's going to be different types of sports activities. And then the second one was art activities. So our sports activities are going to, in this case, represent our columns. So if we take a look here, we have soccer, baseball, and then our art activities are going to represent our rows, which are painting and sculpting. So here it says 13 campers chose soccer and painting, 9 campers chose baseball and painting, and 20 campers chose baseball and sculpting. So construct a two-way table that summarizes this data. So if we take a look here, they gave us certain numbers to fill into this table right away. So some of the numbers that they gave us were 13, which goes right here. They gave us 9 campers who choose baseball and painting, right? So if we look here, this is baseball and painting. And then they also gave us 20 campers who chose baseball and sculpting. So again, baseball and sculpting would go here. So now, once we have these three numbers, we could start to add up our totals here. The totals are important for us to find the missing value because remember, we don't know this 3 yet. They didn't give us that 3. But the other thing they did give us is that there's 45 campers total, and each one chose one sports and one art. So the first thing we want to do is calculate our totals. So if we look here, 13 plus 9 is 22. Then we could also add up our 9 and 20 to get 29 here. Now, we didn't know this number here or this number here, but we do know that 22 plus something has to get us to 45. So when we're looking for that, right, if we took 45 and subtracted 22, we'd get that this total had to be 23. So that means if we know baseball is 20, then that means soccer and sculpting had to be 3. And that's where we can fill in our number there. So we're using some of the data that they gave us, like 45 campers, to find some of our missing pieces there. When we go through the problem set later, after the end of this, we're going to construct one of these on its own so you can see a little bit more clearly how we go about it that way. All right, so next it says two-way frequency tables, or two-way tables show frequency or numeric counts of data. A joint frequency is each number represented by the intersection of a row and column of categorical variables in a two-way table. So important word here, joint frequency. It's represented by the intersection of a row and column. So when we're talking about our joint frequencies, we're looking at all the frequencies inside of our table here. So when we take painting and soccer, where they meet is a joint frequency. So in the tables, the numbers 13, right, 9, 3, and 20 are joint frequencies. A marginal frequency So a marginal frequency is each total for the categorical variables in a two-way table. So the marginal frequencies are in the margins, right? At the very far to the right or to the very bottom here. So if we're looking at this chart here, our marginal frequencies are 22, 23, 16, 29, and 45. They're on the outside of our table there or in our margins. Two-way tables also show relative frequencies. Relative frequencies is the ratio of a value within the frequency table to the value of a total. For example, in the above question, the relative frequency of a camper that chooses baseball and painting, so if we go here, chooses baseball and painting, is 9/45 or 0.20. So if we're looking for baseball and painting, right, we're looking here. These are the students that choose baseball and painting. If we wanted to write that as a fraction or a ratio, right, we would write 9 over the total number of students we're looking at, which is 45, because here they're talking about all the students. And then that can also be simplified down to a decimal at 0.20, right? We could also write this as a percent. 0.20 would be 20%. So you're going to see different ways to represent things throughout this here. So here, when we take a look, a relative frequency can be written in tables, can be written as decimals or percentages. A relative frequency table is a two-way table that summarizes the relative frequencies of each joint and marginal frequency in the table. So, continuing on here, sometimes a specific categorical variable in a two-way table is examined. This variable represents the condition of interest. A conditional relative frequency compares a frequency count to the marginal total of the condition of interest. So here it says, for example, the condition of interest in the first row of sample question S1 is painting. The row conditional frequency of campers choosing painting and soccer is 13/22, or approximately 0.591. This conditional relative frequency indicates that approximately 59.1% of campers who chose painting also chose soccer. So if we look closely at our table again, what they're saying is sometimes we don't want to look at the total of all the campers. We just want to look at a specific set of campers. So this sample was saying what percentage, all right, or what was the relative frequency of people who chose painting that also played soccer. So if we were doing that here, now our new total is all the people that chose painting, which is 22. So that would be our denominator. And then they want to know the number of students that played soccer and chose painting, which is 13. So now we're no longer talking about all of the campers, right? We're only talking about those who chose painting, and then we're looking at how many of those that chose painting chose soccer. So we're breaking it down to a smaller group and using a smaller total because of that. When we look at sample question number 2 here, it says, Felipe surveyed students at his school about whether they play a musical instrument or play a sport. The results of his survey are shown below in the two-way table. So if we're taking a look here, the top has to do with instruments. So whether they play an instrument or they do not play an instrument. That is our first categorical variable. So that would be a yes or a no question. On the rows here, we have whether they played a sport. Again, yes or a no question. Here we have the total number of students surveyed, which was 60. Right? Here's the total number of students that played a sport, the total number of students that did not play a sport. Then down here we have the total number of students who played a musical instrument and those that did not. Notice how our marginal totals here, 15 plus 45 equals 60, and also 27 plus 33 equals 60. So here it says, what is the column conditional frequency of students that do not play a musical instrument that also do not play a sport? So now we're just looking at students that do not play a musical instrument. So we're just looking here, right? So it's just focusing, this is our total set here, our students who do not play a musical instrument. So when we're looking for our denominator here, that total will be 45. We're no longer looking at all the students, but just those that do not play a musical instrument. And then we want to know, out of those who do not play a musical instrument, how many do not play a sport? So we'd look where that intersects here with do not play a sport, which is at 27. So we'd have 27 over 45 as our answer. If we look here, right, we don't see 27 over 45. So using a calculator, you could simplify that to a decimal, which gives you 0.6, which is here, choice D. Notice that this is also equal to 60%. So that's saying that 60% of those who do not play a musical instrument do not play a sport either. So as we continue on here, some data in two-way tables may have very low or very high regular frequencies or relative frequencies. These statistics may lead to possible associations between the two variables. The possible association is strongest when conditional relative frequencies are significantly different. However, observed associations between two variables do not necessarily mean causation, that one variable causes the other to occur. Further study is needed before such conclusions can be made. So we're going to take a look at causation, whether, say, in this case here, if you do not play a musical instrument, does that cause you to not play a sport? Or is it just that they have similar numbers in that sense there? All right, so to take a look at causation, we're going to take a look at the sample problem number 3. So here it says that Savannah asked a random sample of 100 of her classmates about how many hours they use the internet each week and if they have a part-time job. So we're looking at our two categories of hours of internet use each week and if they have a part-time job. So based on the results of her survey, Savannah made the two-way table shown below, and she calculated the row conditional frequencies, relative frequencies, to the nearest thousandth. So if we take a look here, she's got the hours of internet right on top. So we have 5 hours, between 5 and 10, and then more than 10. And then she's got whether they have a job in our rows here. Then she found the relative frequency for the rows, which means that if we take a look here, she looked at how many people have a part-time job, and then of those people that have a part-time job, how many are using less than 5 hours of internet a week, how many are using between 5 and 10 hours of internet a week, and how many are using more than 10 hours of internet a week. Remember here we have decimals. We could also change these to percentages too. So this could be like 50%, 30%, and 20%. Then down here we could have 8.3%, 30%, and 61.7%. Sometimes it's a little bit easier to look at percentages. We're used to looking at whole numbers rather than decimals there. So you might be able to see a pattern a little bit more clearly there. So if we look at this data, 50% of those who have a part-time job use less than 5 hours of internet a week, while 8.3% who don't have a part-time job use less than 5 hours of internet a week. So there's a big difference here, right, between 50% and 8%. So we're seeing that there might be some sort of relationship between having a part-time job and how much internet you can use. We take a look at how many use between 5 and 10. Well, that seems pretty even there, right? They're both 30%, so that doesn't show us that there's a huge difference. But then when we look here at the end, people who use more than 10 hours of internet a week, 20% of those who use more than 10 have a part-time job, while 61.7% of those do not have a part-time job. So again, a big difference here. So when we take a look at this trend here, right? Those who do not have a part-time job tend to use more internet than those who do have a part-time job or more hours of internet during the week. Now, can we say that having a part-time job causes you to not use the internet and not spend a lot of time on the internet? I don't quite think so, right? Because we still have a good amount of people who do go on more than 10 hours a day. But we can say that there is a possible relationship because we do see a pattern here. So we're taking a look at the conclusions, right? Not having a part-time job causes the hours of internet use to increase. So if you do not have a part-time job, does it cause the hours of internet use to increase? We don't quite know about this word cause because we do have students who don't necessarily increase their use. So we're not going to say that one's not correct there. B, not having a part-time job does not cause the hours of internet use to increase. Again, we're not quite sure there, so we don't want to be definitive and say that it causes or not causes. C, there's a possible association between having a part-time job and the hours of internet use. This is going to be our choice here, right? Because we see that there could be a possible association. If you work, you have less time to use the internet. If you don't work, you have more time. Let's take a look at D. There's not a possible association between having a part-time job and the hours of internet use. Well, that's not correct because we do see a pattern. We're just not completely sure why that pattern exists. So we can't say there's a definitive cause, but we can say that it does look like there's a possible association. All right, now we're going to take a look at segmented bar graphs. So statisticians not only use two-way tables to show the relationship between two categorical variables, they also sometimes use segmented bar graphs. A segmented bar graph uses stacked bars to show the different options of categorical variables. Each bar is divided into segments with lengths that indicate the proportion or percentage of observations in the second categorical variable. So here we're going to show a little bit a visual way to show how this data can be displayed. So to make a segmented bar graph from a two-way table, first identify if the relative frequency of rows or of columns has been computed. If the relative frequency of rows, the categorical variables in the rows represents the horizontal axis, and if it's the relative frequency in the columns, the categorical variable in the columns represents the horizontal axis. So for each option, in the second variable, draw bars stacked upon each other, show their corresponding relative frequency. Lots of crazy words there, but it doesn't really make a huge change in, or it's not really as difficult as it seems. It's just telling us which one we're going to put on the x-axis and which one goes on the y-axis when we're talking about graphing the data here. So here it says a principal surveyed random students from each grade at her high school about whether they would be in favor of starting the school day 15 minutes earlier. The two-way table below shows the conditional relative frequency of the yes or no responses of each grade level. So far they didn't tell us, right, whether or not to do it on a horizontal, whether or not to it's a row conditional or column conditional. But they asked freshmen, sophomores, juniors, and seniors whether they wanted to start the school day 15 minutes earlier. These are the people that said yes and no. So here it says create a segmented bar graph that shows the data in the two variable relative frequency. So here, if we're going to do this, right, the difference that we're going to look at here, we're going to take a look and put the yes and no on our horizontal axis. And then what we're going to do is when we're graphing going up on the vertical axis, that's where we're going to put the responses of freshmen versus sophomores. So if you take a look at this table here, this is all the relative frequencies. Now, if we want to figure out whether we put the horizontal on the bottom or on the vertical axis, we just want to see which way adds up to 1 here. So if we were to take our calculator real quick, we'd see that if we add the columns here, right, so it's 0.347 plus 0.101, we see right away that that equals 0.448, which isn't 1. So we know that we didn't calculate the frequencies, relative frequencies going with the columns, but it looks more like the rows here. So if we added up these four numbers, we should see that it's 1. So if we do 0.347 plus 0.273 plus 0.207 plus 0.174, we see that that does add up. So we see a little bit difference there. That probably has to do with rounding, but that does add up to about 1 there. So when creating the table here, right, we take these relative frequencies and we're just graphing them here on this table here. So we have yes from 0 to 1, right, and they counted by 0.2, 0.4, 0.6, 0.8. And we've got a nice key over here that shows freshmen, sophomore, juniors, seniors. So if we take a look, freshmen, 0.347 freshmen, right? So this is the same as 34.7% of freshmen said yes, they wouldn't mind starting the school day earlier. So if we take a look here, this bar, this distance is about 0.347. Then the next one here, which is sophomores, is 0.273. So if we were to add on top of it, this bar, this size would be 0.273, followed by the juniors, which is the next one, which would be 0.207, and finally the seniors, 0.174. So we're just adding these frequencies. They take up this much space of the bar, knowing that the bar starts from 0 to 1, and it helps us to compare the answers. So if we take a look, we can see that the freshmen, right, more freshmen said yes than no, right? And it was a pretty good chunk of the freshman class, while tons of seniors said no relative to yes, right? And we could see that the sophomores and juniors were kind of pretty even in terms of whether they said yes or no there. So that's something that you can see using a relative frequency table in this way. If you look at the bar charts there. All right, so now we're going to take a look at the practice questions, starting with practice question number 1. So practice question number 1 says, the two-way table below shows the subjects students studied for and whether or not they studied independently or with a group. So here we want to know the relative frequency of students who studied independently. So if we want to know the relative frequency, this isn't conditional, right? Because we're just looking for students who studied independently. So what we need to do is find the total number of students and then find the total number of students who studied independently. So first we could fill in our totals down here. So again, totals, right? And then also totals. So if we're adding here, 11 plus 9 is 20, plus 16 is 36, 12 plus 8 is 20, plus 4 is 24. Then we have 36 plus 24 is 60 here. If we keep going down here, we can add across. This doesn't matter so much because we're looking for independently, but we can just add across to fill in the table here. 11 plus 12, 23, 9 plus 8, 17, 16 plus 4, 20. If we were to double check, this would also equal 60. So if we're looking for those that studied independently, right, it was 36, because that is our total for those who studied independently, out of the total number of students, 60. And if we were to find this as a decimal, we take 36 divided by 60, have to use a decimal point to make a decimal, and we'll see our answer is 0.6. So this is equal to 0.6, which is choice D. So here we're able to use the total number of students because they wanted the relative frequency of students who studied independently. There was no other data to consider there. The next one says, a deli offers 2 types of bread and 3 types of meats for sandwiches. The two-way table shows the relative frequencies of some sandwiches types the deli sold one afternoon. So what is the relative frequency of salami sandwiches on wheat bread? So we're looking salami sandwiches and we're looking on wheat bread. So first let's fill in our table here with what we can. So here, if we take a look, we know that there's 14 sandwiches that were made here with wheat bread that were turkey, but the total number of turkey sandwiches was 28, which means that up here we'd also have 14. Then if we take a look here, we start adding up some other stuff here. We see that 20 sandwiches were ham. The total number of ham sandwiches were 32. So to get from 20 to 32, we'd have 12 ham sandwiches. Now we could start going horizontally here. So we know the total number of sandwiches of salami added up to 20. But if we wanted to find the totals that go in here, we see this one adds up to 32. So 14 plus 12 is 26. So we need 6 more to get to 32. And then if we're looking here, 6 plus what gives us 20? Well, that would put 14 salami sandwiches here. So if we wanted to find the total relative frequency of salami sandwiches on wheat bread that were sold, we're looking for the salami sandwiches on wheat bread, which is 6, over the total number of sandwiches sold, 80. Again, we don't see 6 over 80 here. So to find this on our calculator, we take 6 divided by 80 with our decimal point, and we see that it's 0.075. So this is equal to 0.075, which is choice B. So far we've just been taking a look at relative frequencies, right, which aren't conditional. So they're always going to use the total here that we have, which is the total number of sandwiches sold here. So we're not looking for how many salami sandwiches were sold on wheat. We want to know how many salami on wheat sandwiches were sold total. And that frequency was 0.075. All right, going on to question 3. Question 3 says, the two-way table below shows the results of a survey done by a car dealer. So we have different types of cars. So a sedan, minivan, truck, or a different type of vehicle. And then we have men and women. And if we take a look here, we have which statement best describes whether there is a possible association between gender and the type of car a person owns. So first, what they did here is if we take a look, they said women and men, right? And they found the frequencies relative to each here. So 0.4% of women, or 0.4 women out of every one, or 40% of women own a sedan. 45% of women own a minivan, and 15% of women own a truck. If we take a look at men, 50% of men own a sedan, 10% of men own a minivan, 2% own a truck, and 2% own another vehicle. So which statement best describes whether there's a possible association between gender and the type of car that a person has? So if we're taking a look, we're looking for the differences in conditional frequencies. So in terms of sedans, not much difference. In terms of minivan, huge difference here. This is 10% to 45%. So we do see that there's probably some sort of association here. Again, not much difference here or in the last two. So here, if we see, it says the differences in joint frequencies suggest that there's an association. Well, here we're taking a look at conditional frequencies here, right? So we're not looking at relative frequencies. So if we're we're not looking at just frequencies. Next, the differences in joint frequencies suggest there is no association. So when we're taking a look here again, we're not looking at joint frequencies here, right? We're looking at relative to their gender. Here it says the differences in conditional relative frequencies suggest that there is an association. So here we do see this difference in conditional relative frequencies. So that does show that there's an association, which is our answer. And D, the differences in conditional relative frequencies suggest that there is not an association. Well, when we see a difference, so if there is a big difference, it does suggest an association. So here we do see a difference, but that does suggest an association. So it'd be choice C here. So again, we're talking about conditional relative frequencies, which is different than our joint frequencies like we saw in the first two questions. All right. Moving on to question 4. Question 4 says, members of a volunteer group went to 3 different locations last month to volunteer. The two-way table below summarizes how many members volunteered at each location. So here, create a segmented bar graph to show the percentage of females and males that volunteered at each location. So if we want to see the percentage of females and males at each location, our females and males are going to be on our x-axis here, or on our horizontal axis, with the percentages on our vertical axis here. So I'll just go across here. So we have females, then we have males. If we're creating a segmented bar graph, I'm going to do percentages here. So this will be 100%. And then I'm going to do my best here to break this down. So let's say that halfway between 100 and 0 is 50%. Here we have 0%. And then, let's go. So we go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So it's not perfect, but it doesn't really have to be as we're going along. So 80%, 90%, 100. So now we need to see what percentage of females worked in each of these occupations. So if we're doing this and we want to find the percentage, we need to take the total number of females that worked at the zoo divided by the total number of females, right? Because we're not showing females working in the zoo over a total population, but just relative to their gender here. So we're going to take each of these numbers here for zoo, community center, and hospital and divide it by our denominator of 13 to find the percentage here. So I'm just going to write this over here. We'll do again females, and then we'll go through each one. Here this will just be the percentage so that this table isn't too crowded here. And we'll do the same for males. So starting on our calculator, if we want to take a look here. So for zoo, I guess we can go down here. For zoo, we take total numbers in the zoo, 6 divided by 13. And then I want to change it to a decimal, hit enter. I get this number here, change it to a fraction, multiply by 100. And we get it's about 46 percent. Here we'll just keep it whole numbers because there's no way we're going to be able to graph that specifically there. The next one here at the community center, we do the same thing. 3, right, divided by 13 with our decimal point times 100, and we get that it's 23%. Right at the community center, then at the hospital, 4 divided by 13 decimal point times 100, we get that to be 31% if we're rounding here. 31%. Now we can go through and do the same thing with the males here. Now though, we have our numbers 296, but we're dividing by the denominator 17 because that's the total number of males. So the first one here is 2 divided by 17 times 100. We find that to be about 12%. Right, so if we're rounding to the nearest percent, 11.7 rounds up to 12. Continue, 12 divided by 17 times 100. 70% or 71%. And then the last one, 6 divided by 17 times 100. We get 35. Oh, sorry, this middle one here we made a mistake. So this one is 35%. But here, for this last one here, I used the numerator of 12. I was looking here at the total. Really, it should have been 9. So 9 divided by 17 times 100 is 53. That makes more sense. Because remember, we're looking for all of these numbers to add up to 100. So when I saw 70 and 30, I thought, oh, that doesn't add up to 100 because we have to add that 12 in there. So now what we do is we just are graphing these on here. So if we're looking at females, if we're taking a look here, we want to make our key. So we'll say over to the side, we have zoo, community center, and we could say hospitals. Zoo, I guess we can make that pink. Community centers, green. And the hospitals can be yellow. So if we're looking females, 46% of females worked at the zoo. So the first one's always the easiest, right? Because we just have to go up to about 46, which looks like it's about right here. So that's how many worked at the zoo. If we're looking at males, it was about 12%, which is just right about there. Now the next one, community centers, was 23%. So if we want to find out how far we have to go, we're at 46, so we need to go up 23%. So we're going to go all the way up to like 69%, right about there for community centers. So this segment was about 23%. When we take a look at, for men, started at 12, we need to go up 53%. So if we're going up 53%, from 12, we're going all the way to 65, which is about right, about there maybe. And then finally, the last chunk here, these are all going to go up to 100. So we know that because if we're here at 69 and we add 31, we get to 100. But also we know that it's going to represent 100% of our population. And same with men here, goes up to 100. So just by taking a look at these charts here, right, it says based on the segmented bar graph, explain whether or not any association may exist between gender and their volunteer location. Well, you see big differences in the relative frequencies for zoo, right? So this compared to this, and also for the community center. So if we're asking if there might be an association, then I would definitely say yes, there could be an association because we see the big difference in the relative frequencies there. So there, our answer is yes. Because we see a big difference. All right, taking a look at the last question here. Some of these questions have a lot of work, but it's good practice. The last one here says the football team sold t-shirts and sweatshirts to raise money. Each t-shirt and sweatshirt came in small, medium, and large sizes. The football team sold 120 t-shirts and 75 sweatshirts, 400 small, 40 small, 65 medium pieces of clothing, and 55 large t-shirts and 15 small sweatshirts. So here, if we want to make a two-way table here, we're going to make a table. And what we're going to have here is on the left side of the table, right, we can put our t-shirts and sweatshirts, and then we have our totals. All right, and we're creating this grid here. Then on the top, we'll have our small, medium, large, and totals. So your table hopefully looks a little bit better than mine, but it doesn't. Now, here, it told us that there's 120 t-shirts total and 75 sweatshirts. So if we're looking at t-shirts, the total, 120, we put that information here. Sweatshirt, 75. So they helped us fill in our totals over here. Right away, we can also fill in the total number of shirts sold. So 120 plus 75 is 195, right? Because we added these two to get that final one down there. Now, it says that there was 40 small pieces of clothing. So it doesn't tell us whether it's t-shirts or sweatshirts. So that means 40 small for the total down there. And 65 medium pieces of clothing. So right away, we can fill in this space here by taking what we have there, a total, subtract 65 and 40. So 195 minus 65 minus 40. We get that to be 90. So that means that there's 90 large pieces of clothing that they sold. Now we'll fill in the last two pieces of data that they gave us. So it says 55 large t-shirts. So if we're looking for large t-shirts, this is now a joint frequency here. It's 55. And 15 small sweatshirts. So small sweatshirts, 15. Now we have enough data to fill in the rest of the table. So we'll start with small pieces of clothing. There's 40 total small pieces of clothing. We know 15 are sweatshirts. To find the t-shirts, we take 40 minus 15, which is 25. Then, if we want to jump to medium stuff here. Now, medium, we can't go through the column here, right? Because we don't have two pieces of information. But we can go horizontally. We could see that t-shirts, there's a total of 120 sold. We know 25 were small, 55 were large. So to find how many were medium, we subtract 25 and 55 from 120. So I would start by adding 25 and 55, right, which gives us 80. And subtract that from 120. 120 minus 80 means 40 medium shirts here. Now we can go through our column here vertically. If we have 40 medium pieces of clothing that were t-shirts, and we have a total of 65, we can subtract 65 minus 40 and get 25 here. Then finally going across here, we could say that there was a total of 75 sweatshirts. If we want to find how many were large, we subtract the medium and the small. So 15 plus 25 is 40. 75 minus 40 gives us 35 large sweatshirts. So now we go through the question. It says, how many medium sweatshirts did the football team sell? Medium set sweatshirts, 25. So your answer is 25 medium sweatshirts. So making this table, right, the main thing is to organize your table, then fill in the information they give you, and use that to find the information that you do not know. So this is a pretty long video, a lot of stuff here, a lot of work to do, but hopefully we went through the questions there. And then also reach out if you have any other questions or need more clarification. We could set up some times to meet. All right.